Good afternoon. This is a quick overview of the new scripting capability for GDS-SR. I'm going to do a project we call Amber. And Amber has 5 different die in a 5x8 reticle, and there's also 2 target die. And I want to put those onto a 300mm wafer, get them all arrayed out. That'll be my input for clipping through the H-extract program. So you can see I've got a directory here with all my die in it, and I've also got this script file called amberscript.txt, and that's what's going to drive this whole process. So let's have a look at Amber script. Basically, this script file has a series of sections and data. We can put comments with the semicolon. So the first section's database and defines it as GDS-SR in the version and the units. That's important. Then we need to specify 2 directories, one where our temp data will be, and I've specified it to be in a directory called Amber Working Temp, and where our outputs will go, and that's Amber Working Output. And those should exist. Now I define the wafer. It's since I'm working in units of microns, I have to define it as 300,000 microns instead of 300 millimeters. I've got a margin of 3,000, and I've got no flats. I've asked it to generate any die that fall into the margin because I'll need those for sacrificial clipping. Now there's 2 sections. You can use one or the other. If you only are working on a single die, there'll be the stepping section, which defines the step size and the streets and any offset and whether it's centered on the die or the street. However, in this case, our data is coming to us from the foundry in reticle format. So we're going to enter the data that the foundry supplied us. They told us that it was a 5x8 reticle. They gave us the step size of the devices inside the reticle, and they gave us the reticle offset from the center of the wafer. That's the data that we put in. From their diagram, we also identify in this 5x8 array which die are going where. You can see die number 1's here, 2, 4, 5, 3, and then 5. So it's a mix there. The next thing we have to do, of course, is to list all the die that we're going to import. In this case, I'm not sure if we need to enter the width, height, and the centers here. I think that's not necessary, but we do need to enter the number of die we're importing, so count 7. Each die is going to get a name, and this index is important because this is what refers to the grid. And then you put the complete path to the file that you want to load. You have to tell the program what structure is the top structure. You assign here your SIMF ID, so I'm just giving die 1, 01, die 2, 02, and so on. The ratio is normally used for mixed things, but we're going to let the reticle define the ratios of die, so we're just going to put that to 0. And color really doesn't matter, it's an RGB value, but we're not going to be looking at any colors, so we don't really care. So we repeat that for all the devices that we want to end up in our array. It's 5 different devices. Let's not forget that we also want to place 2 target die using the change die function, and so we also have to load these. Notice that on the SIMF label I'm putting FF because that's the label you want to indicate this is some kind of an alignment or target die. The next step is to knock out areas where I don't want any die to appear so I can see the underlying wafer. These informations I got from the foundry as to where these little windows are. So I can either specify a window, which will be lower left, upper right, or if I'm knocking out a single die, I could actually specify just a point. In that case, where I'm replacing these dies with the target, I can use the same value for the lower left and upper right, so my window collapses into a point. So you can see here at this coordinate and at this coordinate, I'm replacing whatever die is there with the left die on this side and the right die on this side. And this is the structure. Of course, I want some outputs, I need to configure them. For my GDS2 output, I have some options. I have things like margin, the wafer outline, crosshairs. If I want to see where the knockouts were defined, I get a layer for that. If I want to see the reticles, I get a layer for that. And if I say I want a certain output, then I better define a layer for it. And finally, I define the actual file. Now, there's additional outputs to GDS2. There's a die placement table, which is a simple listing of the die name and the coordinates. If I want that, there's no options. I just give the file name and out it comes. And there's the SIMF wafer map. Again, I give the file name and I give the label, lot label, and wafer label. Finally, there's one more option that I can put in there, and that would be auto close. So this program actually pops open the GDS-SR window and runs it through in script mode. But if I want it to close when I'm done, I need to add this to my script. Finally, there's some color assignments, and you don't need to mess with these because if you're running in script mode, nobody's seeing any colors anyway. Now we can launch this script. So the first part of the script, just start the GDS-SR program, and then the next argument is just the name of that script file. I called it amberscript.txt. / just means in the current directory, or I could put a full path. And then the only other option I'm using right now is the -disable messages. Sometimes when you're running GDS-SR, it'll warn you about a problem and you need to click OK. Well, if you're not there to click OK, then you really get stuck. So by putting disable messages, it tells the program, don't ask the user for confirmation of any kind of message. That's all I got to do, and I should just be able to hit enter now. You can see it. That's it. It's done. Now let's look to see what we actually got. If we look in our output directory, we'll see that there's 3 files have just been created. The GDS2, the die placement table, and the SIMF. So let's look at those. Here's our GDS2. Let's turn off this layer, and you can see that I have the reticle layer that I asked for. I have the wafer and I have the wafer margin, and that gives me a fairly good feel for where everything is. So let's just turn on one of these layers again, and you can see them refresh. And let's zoom in, and you can see now the metallization layer. You can see where these die fall. Here's the margin and good die, and this is the margin areas outside the wafer. We can probably find our target pretty easily. There it is. So there's our target device on the left that's been dropped in. If you wanted to know where it is, you could turn on your cell markers, and then you could just do an info on the target. Okay. So there's our GDS. All the layers that were in the actual unit files have been transferred, as well as the additional layers I defined, the cross sections. Now let's have a look at some of the other 2 files. Here you can see the SIMP file that we created. And there's our left target. You see it's marked as FF. It's the right target. And finally, here's our die placement. It simply gives you the die name / structure and then the center of the die. So that could be important to a spreadsheet. Anyway, you've seen how this whole process runs. It's extremely fast, and the key is to preparing a script file. Some of the parameters in the script file can be easily gotten when you run it manually, the program manually, and save the config. The reticle information can be gotten by also running the reticle dialog box and saving the results of that after you've filled in all the various fields. You can copy and paste that into your script.